Okay, so last sequence or last type of sequence we're going to look at is a quadratic sequence. So a quadratic sequence, so thinking of the ones we've previously had, we had our arithmetic sequence which had a common first difference. Quadratic sequences typically have an n squared in the nth term. So a quadratic sequence might be like the one here where it's 1, 4, 9, 16, 25, or like 1 squared, 2 squared, 3 squared, 4 squared, so on. And if we look at the difference between those, the first difference, 3, 5, 7, kind of like one we've seen before, 11. Looking at the second difference then, so the second difference is the difference between the differences. The difference between each of those, each of the first difference terms, is just 2. So we have a common second difference, and that is actually a key point of a quadratic sequence. So a quadratic sequence has a common second difference. Okay, so a quadratic sequence has a common second difference. So we look at the second difference to see whether it's a quadratic sequence. This can be really important, I suppose, in coming up with later terms. So if we're told here that this is a quadratic sequence, and they tell us to find the first and second differences to come up with then the next 3 terms in the sequence. So looking at the first difference, I suppose, looking at just the difference between each of them, we can work those out fairly quickly. 1, 3, 5, 7. Looking at the second difference then between those, we're ending up with really the same thing we just had. The second difference is just going to be 2. So to find the next term, the second difference has to be 2 because that's constant. That means that the next number in the first difference is 9, which means that the difference between the previous term and the next term is 9. That's going to give us an answer of 28. Okay, we do something similar for the next term then. And second difference has to be 2. So the next first difference is going to be 11. And the one after then would be 13. Okay, looking at how that relates then to our terms, the next term would be 39. And the next term then should be 13 more than 39. Okay, 13 more than 39, which is going to give me an answer of 52. Okay, so if we're given something like that where we're asked to use the differences to come up with the next terms in the sequence, it's just making sure we're being consistent. So writing out your second differences, using that to find your first differences, and then knowing that you need to go further and find the individual terms as well. Now, as we've done with everything that we've looked at so far with our arithmetic sequences, even with the arithmetic series, we saw that there is a formula or a rule that we use when we're finding these terms. And the quadratic sequences are exactly the same. We have a formula to find the nth term of a quadratic sequence. So Tn is equal to an squared plus bn plus c. An squared plus bn plus c. What's important with this one is that it is not in the log tables. So you need to learn. You need to know this one. Now the formula is the same as kind of our general quadratic. So we're used to that idea of saying ax squared plus bx plus c. So we can kind of think of it that way. It's a quadratic sequence, so the formula is just a quadratic. The other key thing to remember is that the second a in this term is the second difference divided by 2. Okay, so in the previous ones we had a was maybe the first term. With this section here, a is the second difference divided by 2. And we already have kind of said there that for a quadratic sequence, the second difference is constant. So if we're finding the nth term, like in this example here, the nth term of the sequence, we remember our formula, Tn is equal to an squared plus bn plus c. So to find the nth term of the sequence, we need to work out each of those letters as best we can. Now we know a is the second difference divided by 2. Okay, very important that we're aware of that. So in order to get that, obviously we have to find out what the second difference is. The first difference in this case is going to be 7, 11, 15. My second difference then is the difference between those, and that's an answer of 4. So in terms of a, then a is my second difference, which is 4, divided by 2, which gives me 2. So a is equal to 2. So for our formula, we have an squared plus bn plus c, and we can sub in that value for a. So 2n squared plus bn plus c. Now you'll notice here again, we have 2 letters that we don't know, b and c. Okay, b and c, we don't know the values of those. What we should remember from our arithmetic sequences is that if we have two unknowns, that generally means that we're looking at doing simultaneous equations. How are we going to come up with those equations? Well, we need to look back at the sequence. We know that the first term is 3. So if we were to write that out, t1, which is 2 by 1 squared plus b by 1 plus c, should be equal to 3. So we get 2 plus b plus c is equal to 3, and then b plus c is equal to 1. Okay, and that's our first equation. If we look at the next one, the next term, t2, is equal to 10. So t2, which is 2 by 2 squared plus b by 2 plus c, is equal to 10. 2 by 4 plus 2b plus c is equal to 10. 8 plus 2b plus c is 10. So 2b plus c is equal to 2. Okay, and those are our two equations then. So b plus c is equal to 1. 2b plus c is equal to 2. Lovely. Okay, then same as we did the last time, if we multiply one of the equations by -1, that will make it easier for us just to eliminate one of the variables, one of the letters. So minus b minus c equals -1. 2b plus c equals 2. B is equal to 1. Okay, so we get b is equal to 1. We sub that back in. B plus c is equal to 1. So 1 plus c is equal to 1, which makes that c then is equal to 0. So our answer for Tn is 2n squared plus bn, which is just 1, so plus n, and plus 0 if we wanted to. And that's our overall answer for Tn. Okay, the difference here, there's really not a lot of difference here between finding A and D and finding B and C in these questions. We use the terms that we have. We know what n is for those terms, and we know what the answer is, so all that we have left is B and C. You just need, again, to be careful that you're familiar with that method. So first of all, knowing for definite which type of sequence it is, so knowing that it's a quadratic sequence, being able to sub in your value of n, and using that then to find out those other values, b and c, using your simultaneous equation. And then that gives you your general formula for the quadratic. So Tn is equal to 2n squared plus n. And then if we wanted to find any particular term in this sequence, we could just sub in for n. So if we wanted the 5th or 6th or 7th, we could just sub in for those values of n.